Hey guys, Miss Hanley here. So this video is for the trigonometry unit, Unit 5, and this goes with assignment 4. We're going to start talking about something called the unit circle. So next, or first, I guess, and I apologize if I start rambling in this video, I'm super tired, so I'm going to try and make it as clear as possible and as quick as possible. But just in advance, I'm apologizing. Okay, so in your notes you'll find the section that says Unit 4 or 4.2 Unit Circle. Woohoo! Unit circle is one of those things that it is going to be so helpful for you to memorize when you get to calculus. It makes so much of the stuff that you have to do in calculus faster, and there's not a lot of things that I really suggest that you should memorize, but probably the three things that I would memorize would be your multiplication facts when you're young, the quadratic formula, and the unit circle. If you were going to ask me three math things to memorize, that would be it. So at certain points throughout the rest of the quarter, you're going to have unit circle quizzes where you'll have to fill it in from memory. So starting to learn it now, and I'll show you some tricks to help you remember it, but this is going to be really important in this section here. So let's start by finding this page in your notes, and today we're going to talk about the 6 trigonometric functions. So for most of you, you've heard of the sine function, cosine function, and tangent function when you did SOHCAHTOA. There is also the cosecant, secant, and cotangent function, and their abbreviations are below. And as you know, we've been thinking about the radian measures on a graph, and so using that same idea of the graph and our angles, we can actually find these 6 trig functions, the values of these 6 trig functions at specific angles. We just have to know where they fall on that graph. And because that graph of the angles makes a circle, we're going to talk about it as the unit circle. So anytime you're given a point that falls on your unit circle, it would be a point on the graph that would actually lie on that circle. It's going to correspond to certain parts of the 6 trig functions. So you're always going to get a point, x and y. And each point on that circle, the y value is equal to the sine, right? So let's say we get the point on the circle that is 0, 1. That's my point. Well, then the sine of the angle that makes that point is going to be just the y value, which in this case would be 1. The cosine is the x value, which in this case would be 0. And tangent is y divided by x, which we know as sine over cosine. Okay, so in our case here, my sine is 1 and my tangent is 0, but this key piece here says that x cannot equal 0. That's your domain restriction. So if I end up with 1 divided by 0, that tells me that this tangent is actually undefined for this point on the unit circle. The other 3 trig functions are really simple. They're just the reciprocals of each of these 3. So cosecant is the reciprocal of sine, and so it would be, instead of 1, which is y, it's 1 over y. In this case, it's 1 over 1, which would still be 1. So for this particular point, it happened to be the same. Generally, it will be different. Secant is the inverse of cosine, and so you're just taking the reciprocal of the cosine. If we get 0, it's 1 over 0, which would again be undefined. And then cotangent is the reciprocal of tangent, or it's x over y, or cosine over sine. Alright, and so in this case we'd have 0 over 1, which would just be 0. Now if you flip to the green packet of notes and things that I gave you, one of those pages is a blank unit circle, which we'll fill in a minute. The other is a list of trig information. And so these same ideas, these same concepts should be on that sheet somewhere, and we'll use that when we get back from vacation more and more. Okay, so we're going to derive the unit circle right now. We call it the unit circle because it has a radius of 1, so that's an important thing to note. And we're going to chop it up into angles that are either 90, 30, or 60 degrees, or 45 degrees, or increments of those angles, okay? Multiples of those angles. And because we're going to do that, we're going to create special right triangles. So we're going to create 45, 45, 90s and 30, 60, 90s. So think back to geometry. When you have a 45, 45, 90 right triangle, the two sides are congruent because they're opposite congruent angles. The hypotenuse is that side length times the square root of 2. And so we're going to use that relationship to help us derive some points. When you have a 30, 60, 90 right triangle, the smallest side across from 30 we would write as x or as n. The hypotenuse was double that, and the side across from 60 is x times the square root of 3. So it's a little bit bigger than the side across from 30. Keeping that in mind, here's your unit circle. And let's think about the angles that we already know. Well, here, and sorry, before I go ahead and fill in all these values, you should get out your green sheet that has the big unit circle. It'll be much easier to fill in on that. But okay, so we have 0 degrees over here, which is 0 radians, right? And the point on the circle there, well, if we're going to talk about the unit circle, the radius is 1. So this would make the point 1, 0, right? The next increment up is going to be at a 30-degree angle, and then a 45-degree angle, and then a 60-degree angle. Remember, 30-degree angle was pi over 6, 45 is pi over 4, and 60 is pi over 3. So we want to be able to find the points for this, and I guess we could fill out this top one. You get 90 degrees, which was pi over 2. And again, if this radius of the circle is 1, this makes the point 0, 1. Alright, so we've got that first quadrant down with degrees and radians. And now let's see if we can calculate some of those points there. So I'm going to go to the next page and sort of draw in what's happening. But for the first one, we're just going to let's think about this 30-degree angle right here. If you come straight down from that point and make a right angle, so you find the altitude, we want to figure out the coordinates of this point. But the key piece here is that the radius is always 1, alright? And we know that this was a 30-degree angle. So let's take that and fill it in a slide here. So we have 30 degrees down here. We have 90 degrees here. 30 and 90, then this has to be 60. And we know that this radius is 1, and we're trying to find the point that is created up here. Well, this side, the hypotenuse, is 1. It's also the side that we reference as 2x, right? The side across from 60, as we just looked at, is x times the square root of 3, and the side across from 30 is just x. So if the hypotenuse is 1, and that is 2x, then the side across from 30, which is just x, has to be half of that. So half of 1 would just be 1/2. So the length of this side here is 1/2. And then we get the last side, which is x times the square root of 3, so that would be 1/2 times the square root of 3, or the square root of 3 over 2. So that means we're going in the x direction. We're headed square root of 3 over 2 spaces, so that becomes my x value. Whoops. And in the y direction, we are going up 1/2 spaces, so that becomes my y value. Alright. So if you think about the other angle that we had, so this was for the 30-degree angle, which is also pi over 6. If you think about the 60-degree angle that we created, Well, your hypotenuse is going up higher. So you get 60 here, 90 here, and 30 here, but your radius is still 1. So all that's going to happen is that the 1/2 and the square root of 3 over 2 are switching places. The 1/2 is across from 30, and the square root of 3 over 2 is across from 60. So your point for the 60-degree angle is 1/2, because you're going 1/2 spaces in the x direction. And then it is the square root of 3 over 2 for the y, because that's how far up we had to go. And so when I was talking about the x and y values before, these points that we're finding right here, that is what we're talking about when we're finding sine, cosine, and all of those other trig functions. So the line to derive is the 45-degree angle. So it's coming up at a 45-degree angle. It's a terrible triangle, sorry. Just go with it. And if this is 90 and this is 45, then we have another 45-degree angle, meaning that those two sides should be congruent. And again, my radius is still 1, right? So this side was x times the square root of 2, my hypotenuse, and these sides were both x. They were just the congruent sides. So if I have x square roots of 2 is equal to 1, and I want to find just x, then I have to divide by the square root of 2. And so you end up with 1 over the square root of 2. But if you remember in geometry, we have to do what's called rationalizing the denominator. So you never want to leave a radical in your denominator. So in order to get rid of it, I just have to multiply by it and multiply straight across. You get 1 square root of 2, or the square root of 2, over, technically it's the square root of 4, but the square root of 4 is just 2. So you end up with the square root of 2 over 2 for both of these sides. And so that's your last point, is the square root of 2 over 2 and the square root of 2 over 2. So since all of the other angles in the unit circle are going to be multiples of 30, 45, and 60, you're going to have just those three numbers to really memorize. 1/2, square root of 3 over 2, and square root of 2 over 2. We just have to think about what sign they're going to be and which angle they're going to correspond with. So in that big green unit circle that you have, pause the video for a second and fill in all of those points and all of your angles and radian measures. And this right here, this is your unit circle. So everything has a radius of 1. You have 0 degrees, 30, which is pi over 6, 45 pi over 4, 60 pi over 3, and those are the 3 points that we just talked about. 90 is pi over 2. And then over here you get 2 pi over 3, 120 degrees, 3 pi over 4, 135, etc. Pi is 180, we know that. 270, 3 pi over 2. And back up to the other one would be 360 degrees, or 2 pi. Right? 2 pi and 0 degrees are going to be the exact same value, still 1, 0. So pause the video, fill this in your green sheet, and then we're going to use this in a second. And when I come back from break, we'll talk about ways to help you actually memorize this. Okay, so now let's use those values to evaluate 6 functions at the real number. And so they're giving us t, essentially they're giving us an angle. They might give it to you as theta, they might give it to you as x, but this right here is the angle. And so we want to think about that angle on the unit circle, pi over 6, which would be the same thing as 30 degrees, and think, okay, what point does that correspond with on the unit circle? Well, pi over 6 corresponds with the square root of 3 over 2 and comma 1/2. Okay? And so using what we know about all of our values, the sine of this function, so the sine of t, or we can say the sine of pi over 6, is going to be equal to the y value. So it's going to be 1/2. So very little math involved. You're just really literally figuring out, and when I say math, there's math involved, but little calculation involved. You're just looking and sort of analyzing what you're given. So sine is always the y value. Cosine of pi over 6 is going to be the x value, which is the square root of 3 over 2. And the tangent of pi over 6 is the sine over the cosine. So we get 1/2 divided by the square root of 3 over 2. And to deal with dividing by a fraction, we can multiply by the reciprocal. And so the 2's are going to cancel and we get 1 over the square root of 3. Remember, we don't want to leave the square root in our denominator, so multiply by the square root of 3 over the square root of 3, and you're going to get the square root of 3 over 3. So that's the tangent of pi over 6. And most of the time, once you get a little quicker at this part, you'll be able to do in your head, so you won't really have to write that out. But square root of 3 over 3 is what we'll get there. And so now let's think about the other 3 trig functions that we talked about that are sort of new to us. Well, we said the reciprocal of sine is the cosecant. So cosecant, and I'm actually going to move this up a little bit. Hold on. The cosecant, which we write as CSC, of pi over 6, is the reciprocal of sine. So instead of it being 1/2, it's going to be 2 over 1, or 2. Just flip it. The secant, which is the opposite of cosine, is going to be the reciprocal of square root of 3 over 2. So it's 2 over the square root of 3, which if we rationalize that becomes 2 square roots of 3 over 3. And then lastly, we get the cotangent, which, as it sounds, is the reciprocal of tangent. And so that value there is going to be the reciprocal of what we got. And I like to think about it as that original value we got. So the reciprocal of 1 over the square root of 3 is just the square root of 3 over 1, or the square root of 3. You would have gotten the same thing had you started from this and taken the reciprocal, but you would have again had to rationalize the denominator and to see that the 3's would cancel. So that's how you're going to find your 6 trig functions. I think I'm only going to do that one example with you for now. The others are written out in your textbook on page, hold that thought for a second, page 296, if you would like to take a look at how they found the other ones. Remember, you can get an undefined value like we looked at in the beginning if you ever divide by 0, so be careful of that. Okay, same goes for evaluating trig functions for a negative angle. You just want to figure out what positive angle that corresponds with. So if you go pi over 3 spaces in the clockwise direction, right, so we're going to go down pi over 3, that would be negative pi over 3. You want to figure out the point that corresponds with that. And so that's going to be the point 1/2 and negative square root of 3 over 2, right? So that negative pi over 3, if you think about it, well, 2 pi is going to be 6 pi over 3. So if you go negative pi over 3 spaces, you're going to be taking away 1 pi over 3. So that puts you at 5 pi over 3. All right, and that's where that point comes from on your unit circle. So again, you just want to find the 6 trig functions. This y value is your sine. The x value is your cosine. Your tangent is going to be the negative square root of 3 over 2 over 1/2. And so when I do this, I'm going to have negative square root of 3 over 2 times 2 over 1. 2's cancel, and so I just get the negative square root of 3. So then your other 3 are just the reciprocals of that. So the sine corresponds with cosecant. So the cosecant of negative pi over 3 is going to be negative 2 over the square root of 3. Just flip it and rationalize your denominator. The secant of negative pi over 3 is going to be the reciprocal of 1/2, so 2 over 1, or 2. And then the cotangent of negative pi over 3 is going to be the reciprocal of negative pi over 3. So it'll be negative 1 over the square root of 3. Sorry, the reciprocal of negative square root of 3. So it'll be 1 over negative square root of 3. And then again, rationalize your denominator like we did before. Okay, a couple other quick things here. Thinking about our unit circle, we know that the sine value is always the y-coordinate, and cosine is always our x. And because the unit circle, the radius is equal to 1, that means that our values are never going to be more or less than positive 1 and negative 1. Right? That's how we make that perfect circle, center at 0, radius 1, which is x squared plus y squared equals 1 if you think back to the beginning of the year. So since that's the largest values we use, the domain of the unit circle has to just be between 0 and 1. So that means the domain of all those functions there is, sorry, not between 0 and 1, between negative 1 and 1. The domain of all of those functions has to be the same thing. They're never going to be bigger than negative 1, smaller than negative 1 or bigger than positive 1. They're always going to be in between. Something to remember. Alright, another thing to note is that you can have periodic functions. So I might give you an angle that's bigger than 2 pi or bigger than 360, but remember that they correspond to a smaller value because you have those coterminal angles. So continue to use that idea. Sine and cosine functions correspond to the circle, and every time you go through one revolution, it's just going to repeat the values over and over and over again, and that's why it's called periodic function. When you graph it, it's cyclical. We talked about that before. Keeps repeating itself over and over and over. So if I give you something like sine of 5 pi, you want to think about how many times 2 pi goes into that. Well, the sine of 5 pi is 2 pi plus 2 pi plus pi, right? So it's really the same thing as just finding the sine of pi. Because if you go all the way over to 2 pi, you're back to where you started, so it's not going to make a difference. So keep that in mind if you get an angle that's bigger than 2 pi or 360. Take out the revolutions, the extra revolutions, and just see what you would have left over, almost like a remainder. And lastly, we talked about even and odd functions when we did our function unit. The cosine and secant functions are even. And if you remember, algebraically, that means that if it's even, if you put a negative x into your function, it's not going to change your function at all. You still get the same value. When your function is odd, if you put a negative value inside of it, it makes the answer the opposite sign, or it makes the answer negative. So cosine of some negative value is going to be the same as the cosine of that positive value. And same with secant of a negative value is same as the secant of a positive value. But with sine, cosecant, tangent, and cotangent, so those are the reciprocals of each other, every time you put in a negative angle, your answer turns negative. So let's look at these last two examples here. The sine of negative 2, well, sine is odd, so that means it's going to change signs. So the sine of negative 2 is going to be equal to the negative sine of 2. Alright? And we don't know necessarily what the sine of 2 is at this point, but you could use your calculator, but we know that it's going to turn negative. Cosine, however, is going to preserve that positive value. So even if I put a negative 2 in there, it's the same thing as finding the cosine of positive 2. So those even and odd functions still hold true here. Alright, so please try assignment 4, and when you get back from break, have that ready to go. We're going to talk more about your unit circle, and have a wonderful vacation.